Hello, everyone. Here is a video showing you about using the Apex program for Algebra 1. So I'm going to try to post one video per week where I show you maybe a different lesson or different thing that needs to be done. We can always, though, meet in Zoom. So please remember that we can meet in Zoom 8:51 to 9:26 every day, or 11:23 to 11:58. Those times are open, and I'll be on, and I'll also be on many days after school, 12:40 to about 3. So please do check in on those times if you need help on other lessons, because I won't be able to post videos for every single lesson, but I'm here to help. So what we're going to do is we're going to look just at Unit 1, getting into the program for kind of a refresher for those that have been here before. And if you've never been on Apex before, this will help you too. So Unit 1, overview. We're not going to worry about that. You can click on it if you want to see what the overview is. I'm more interested on you seeing the study. And once you're done the study, boop, you can take the checkup if you want, or go over to the quiz. All right, so I'm going to click on here. And you'll see that the Apex program does have things.
When you work with numbers, it's helpful to know more about how they are organized into types.
Okay, so things like that, where you see the little microphone or the speaker. I'm sorry, not a microphone, a speaker. You can click on that and hear it. But it's just showing you in this lesson about rational and irrational numbers. You probably learned this in junior high, but it's a refresher for algebra. So it's showing you what the natural or counting numbers are, what the whole numbers are, what integers are, fractions, decimals, percents, and what we call real numbers. So natural or counting numbers are all the numbers that we would use to count except 0, because 0 is added into the whole numbers. You notice that there are no negatives, no fractions, no decimals. Again, no negatives, no fractions, no decimals, but you do add 0 here. Integers are the same as these sort of numbers, but you can now add in negatives. So again, no decimals, no fractions, but now you have positive and negative integers. Fractions, we should all know what they are. They have a numerator and a denominator. Decimals, there we have those decimal points. Percent, 12%, 24%, 99%. So percentage numbers have that little percent symbol after it. And then real numbers. So real numbers are all the numbers you see in the world. Rational numbers and irrational numbers. So this is just screen 1 of 17. So I'm going to go through these screens. You see on this screen, every fraction can be represented by a decimal number. You can write every fraction as a decimal by dividing the numerator by the denominator. So dividing the top number by the bottom number. So you see here, if we jump down here, terminating decimals, they terminate like the domineta. 2/5 means 2 divided by 5, which would be 0.4. 7/8, 7 divided by 8, which would give you 0.875. Repeating decimal fractions, 2/9 would equal 2 divided by 9, 0.22222222. And this ... means that it continues forever. It would be 0.22222222, on and on and on and on and on. 1/3, 1 divided by 3 would equal 0.33333, on and on and on and on and on forever. And just so you know, repeating decimals isn't always just the same number repeated. Sometimes you'll see multiple numbers repeated, like you might see 0.24242424 forever, or 0.373737, on and on and on. It doesn't just have to be the same number repeating. And then in here you have the real numbers, rational numbers, integers, whole numbers, natural numbers, and those irrational numbers. Those are those are the repeating decimals that don't show a pattern, etc. So you can click and go through this screen. It shows you examples of rational numbers. This has a repeating pattern. So these would all be irrational numbers. All right, rational numbers and irrational numbers. So it says here, take a moment to compare these two sets, rational numbers. And if you click, you see that it turns, and it gives you some information here. It gives you the algebraic form, a divided by b, but it also gives you an example using just regular numbers, 2/3 and 4. So rational numbers, some examples can represent it by a over b, represented in fraction form, which would be 2/3. 4, which is a whole number. But remember, 4 can also be 4 over 1, which would kind of make it a fraction as well. Irrational numbers, though, on the other hand, irrational numbers are all real numbers that cannot be written as rational numbers. So things like pi, which is 3.14, blah, 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 it goes on forever. Square root of 2, if you put that in a calculator, it would go on forever and ever and ever with no repeating pattern. So those would be irrational numbers. All right, so rational numbers can be written as a ratio of two integers where the denominator is not 0. Decimal representation of rational numbers either end, terminate, or repeat a pattern forever. So that's why I was kind of saying a repeating pattern would also make it rational. All right, so let's take a look here. Use what you have learned about rational and irrational numbers to answer these questions. So when you go through this lesson, do that. What type of number can be written as a fraction a over b, where a and b are integers and b is not equal to 0? So you have to decide, is that an irrational number, all numbers, a rational number, or pi? Okay, and I'm not going to show you the correct answer because you can backtrack. But then once you have your answer, you click submit, and it'll tell you whether it's correct or not. So you want to click which of these would be correct. All right, you have now learned a lot about rational and irrational numbers. Take a few moments to confirm that you know the definitions of these terms of numbers before you go on. Okay, so if you click in the box here, these are all nice little things. It reminds you the definition of a rational number, and it reminds you the definition of an irrational number. And that's what you learned about on those other screens there. All right, now that you can tell the difference between rational and irrational numbers, think about adding two of them together. Suppose you add together two rational numbers, such as 4 plus 2/3. What type of number is the answer or sum? Okay, so if you worked that out, what would 4 plus 2/3 be? Which fraction represents the integer 4? So remember, I hinted that to you earlier. I said 4 can also be written as, and then you have to decide, would 4 be written as 4 over 1, 4.0, or 1 over 4? And when it's asking a fraction, I hope we would eliminate that choice right away because that's not a fraction. So hopefully we should know, and I'll give you a hint here. Boop, it should be choice A. All right, there you go. And then as you click, it gives you other questions to answer and prompts you to look at other things, like what is the common denominator, etc. So you would work that through. Okay, sum of rational numbers. Why is the sum of two rational numbers always rational? Remember, by definition, a rational number that can be written as a over b, where b is 0. So when you add two rational numbers in this form, it's just like adding two fractions. Adding two fractions always produces another fraction as the answer. This means the answer will always be rational. And thank you for not laughing at my voice when I cracked there when I said rational. So there you go. And you can watch the video.
A rational number can be written as an integer, a, divided by a natural number, b. A second rational number can be written as an integer, c, divided by a natural number, d.
So it'll go through and show you the example as you go through the program, as you watch these videos. So take time to watch it, listen, and hear what it is that they're saying. Okay, adding rational and irrational numbers. Here are the rules for adding rational and irrational numbers. So if you add an irrational and an irrational number, your answer will be irrational. If you're adding two irrational numbers, your answer will be irrational. So in other words, making it short, if you're adding anything and an irrational number, your answer is always going to be irrational. In other words, it'll be one of those things that gives you that decimal that continues forever and ever and ever with no repeating pattern. And again, you can watch videos here that show you. Okay, it gives you all the steps. Again, if you have questions here, that's when you hit me up on Zoom. We can jump on and take a look at these different things. All right, so sum of rational and an irrational number. Rational and irrational sums. All right, for each expression below, determine whether the sum is a rational or an irrational number. So you would drag these things into there. And I'm thinking right away that we'll just take a look at one that's rational, one that's irrational. When we have an irrational number like pi, we know that the answer has to be irrational. Okay, and looking for something rational. Okay, two decimals can easily add those and get a rational answer because it wouldn't repeat. Okay, and you hear a little bloop. And when you finish all those, wherever you think they go, you hit submit, and they'll tell you what's right or wrong. And then you can kind of backtrack if you need to make some corrections there. All right, now let's think about what happens when we multiply rational numbers and irrational numbers. So multiplication is a little bit of a different thing. Here's nice. Rational times rational always gives you a rational answer. Rational times irrational looks like it's given us some irrational answers. All right. And here's, prompts you to answer some questions. Like there's 3 questions here. When 2 fractions are multiplied, the product, which is the answer in a multiplication question, can always be written as a fraction, a whole number, or a repeating decimal. So you'd want to pick the choice from there as you look at your samples up here. And you want to answer that and then click on all 3 of those questions to help you. All right, and so here's your hint. Rational times rational equals irrational. Rational times irrational equals irrational. Again, if you see an irrational in there, your answer is going to be irrational. And it gives us an example, okay? Puts it to us in terms of algebra, where it gives us those variables. And same with a little bit more wordy here for rational times irrational, but it gives you further explanation than just the words. All right, for each expression below, determine whether the product is a rational or irrational answer. So again, you would multiply. See, if you have a calculator, great. Again, I see something like square root of 5 is irrational, so I know that that's automatically going to make my answer irrational. Here, I see 2 rational fractions, so I know that that should be rational. And then it's when you submit your final answer, it'll tell you if you're correct or not. All right, remember the rules for multiplying rational and irrational answers. It gives you the step, and it asks you a question. What type of number is 0.7? Is it rational or irrational? You would click your answer that you think and submit, and there's 5 questions there. Here's your chance to practice. Answer these questions about real numbers. Okay, so it's got 4 questions here. Which of the following numbers will produce a rational number when multiplied by 0.6? In other words, if you were multiplying these numbers times 0.6, which of these would give you a rational answer, one that would end, not have that repeating decimal forever and ever and ever? And again, 4 questions there. Okay, and it says, congratulations, you're ready to try sample quiz questions and get immediate feedback. Okay, so you would try these sample questions and then get ready to take the quiz. So hopefully this was helpful. There is also a study guide. If you want to click on it, it will help you. You can print those out from your home printer. But hopefully this was helpful. And again, see me on Zoom or Google Classroom. You can also ask questions. All right, I'll talk to you guys soon.